Good evening, students. Now I welcome you again on my next lecture. The question is, this is also related to the continuity topic. The question is, so that the function, this is a function, what x square, for this x square is valid for this by, or your fx is valid for when 1 is less than or equal x is less than 2, and fx is 3x square minus 4 is only when 2 is less than or equal x is less than 4 is discontinuous. We have to prove this function whatever is given is discontinuous at x is equal to, okay, and this function is continuous at x is equal 3. So we should prove here, and now we will see the proof here. I am taking at first at x is equal to, what will happen, what we have to prove. To prove here, what we have to prove here, we will write to prove what we have to prove. Given function, whatever the function, given function is discontinuous at x is equal to, we will prove discontinuous at x is equal to, but they are the continuous and continuous at x is equal 3. So I will prove here. Okay, so now ready for the proof. At first I will prove this function is discontinuous at x is equal to, at x is equal to. So students, at first we will find out the function is discontinuous at x is equal to. So we need to find what is the value of the function at a given point. So then f of 2. So students, tell me what is the value of function by at x is equal to, what the value of the function by is equal fx is equal what is the value of the function at f of 2. So student, let's see here where the function is equal, where x is equal to. See here at this point you can see here the 2 is less than or equal x, means the value of x is here what, 2. If I am asking to you what is the value in this interval, actually it's a 2 is less than or equal x, means here is 2 is equal x. So your function, means your function by is what, 3x square minus 4. We can't take this because here is not x is equal to, but here is x is already, the value of x is equal to, because equality is apply here. Okay, so your f of 2, or I am asking to you what is the function for this, I write here, then f of x at x, where x is equal to here, so the fx is what, 3x square minus 4. So f of, I need to tell you what is the value of f of 2. So this means at the x we will put what, 2. So this is 3 into 2 to the whole square minus 4. So student, this will give you 3 into 2 to the power 4 is 2 to the power 2 is 4 and minus 4, and 3 4 is 12 minus 4. So this is 8. So the value of the function at x is equal to is what, 8. So now students, I will solve for the limit will be exist or not. See here, for limit existing we need to find out the left hand limit and right hand limit. So left hand limit is what will be the left hand limit, this is equal limit x tends to, we are checking for the x is equal to, so x is approaches to left of f of x. So here students, tell me where the value of x is less than 2. Tell me, you need to find out here the function, what is the value of fx, where, what is your fx, actually you need to find out by, you can say, actually this is also equal by. Okay, so you need to find out where is x is less than 2 and we need to define here what is your fx. Okay, so x should be less than 2 here. So where is x is less than 2? X is here less than 2. See here. So we will, your fx will be x square here. Okay, so this means limit, I will write at this point, limit x tends to 2 left, your fx is what? X square. Why it is x square? Because here is x is less than 2. So students, see next. So limit, so LHL is what? LHL is equal, so limit x tends to, x approaches to left of x square. So this means if I can apply here h tends to here. So let here, if h tends to 0, then what will be effect on the x? Then x will be 2 minus h. Then x is 2 minus h. Okay, so right here, so limit, left hand limit is what? Limit x tends to, it's h tends to 0. Okay, so x square will be what? That will be 2 minus h to the whole square. So this will give you limit h tends to 0. Open this portion, it's in the form of a minus b to the whole square. So this will a square plus b square minus 2ab. So this means 2 to the whole square is 4 plus h to the whole square is h square and minus 2 to the 4h. We will apply 2ab, actually it is in the 4h. Okay, so students, this term and this term will be 0 because h tending to 0. So we are getting here 4. Okay students, so the value of the function at a given point is 8 and left hand limit is 4. So this means you can observe here the function is discontinuous according to the definition of the continuity. If limits are not exist, or you can say if limit, suppose that if limit are existing but the value of the function at a given point are different, so the function, so the curve is discontinuous here. Okay, so let us check for the RHL. What will be the RHL? So now RHL will be limit x tends to, that will be 2 plus 2, right? So we need to find out the what is the function fx here. So at this point here you can see x is approaching to 2 plus, means the value of x should be greater than and 2. So where is x is greater than or greater than 2? So x is greater than 2 here at this. So the function for this is what? 3x square minus 4. Okay, so limit x tends to 2, right? Your fx is what? Your fx is 3x square minus 4 minus. Is it clear, students? Now I'm converting it. So if h is tending to 0, then x will be what? X will be 2 plus h. Okay, means here is x will be 2 plus h. So limit, this implies is equal, sorry, limit h tends to 0. Okay, and this will give you 3 into, what is the value of x right now? It's a 2 plus h. Okay, so we will write a 2 plus h to the whole square and it's a minus 4. So limit h tends to 0, 3 of 2 plus h to the whole square, that will give you, this is again in expression in the form of a plus b to the whole square. So it is again giving you a square plus, that means 4 plus h square plus 2 to the 4h. Okay, and minus 4. Is this clear? Now students, we will multiply 3 within the bracket. So limit h tends to 0 and 3 4 is 12 plus 3h square plus 3 4 is 12h and minus, student, 4. Actually we are not multiplying 3 in the 4 actually. So let's 12 plus 3h square plus 12h, actually both these terms are 0 because h tends to 0. So 12 minus 4, this will give you what? 8. Okay students, so here what you have got, you have gotten, actually you are getting here what? You are getting the value of the function f of 2 is equal, f of 2 is 8 and RHL is also 8. So f of 2 is equal RHL, but RHL does not equal left hand limit. Okay students, so here limits are not existing, so the function is discontinuous at x is equal to. So function is discontinuous, you will write here, is discontinuous at x is equal to. Is it clear? Why? Listen students, for continuity there are two conditions should be satisfied, not a two, it's a three. At first the function should be defined. Here f of 2 is defined, actually f of 2 is defined, it is clear, of course it is 8, but the limits are existing. Limits should be, left hand limit should be equal right hand limit. Here you can see the left hand limit is 4 but right hand limit is 8, so limits are not existing. Because of this, function is discontinuous. But for sometimes what is for the continuous number first, the function should be defined at a given point. Number first thing, limits should be exist, and what are the existing limits? They should be equal value of the function at a given point. Is it clear? So now I will check for the continuity. So please write down on your copy these things and press. Okay students, so now I'm after the proof of the discontinuity at x is equal to, now we will prove the function is continuous at x is equal 3. So now students, see here what we have to prove. The given function is continuous at x is equal 3, and student, this portion is very important to understand. Okay, so first thing is in our mind, what is the function, what is the value of fx, what is your fx at x is equal 3. Listen students, you should understand the intervals here. Listen students, at this portion you can see here we are proving the function is continuous at x is equal 3. So let's see where is x belongs to. So students, see at this interval here 1, this will be closed interval. Actually we are applying closed interval because the value of x is also 1, and here is 2. Applying here open interval, actually the value of x is not equal to. And now students, so this means 3 is not belongs to this interval. Okay, and now let's check for this interval here. So this means that will be closed interval 2 and that will be 4 interval. So let's listen students, this is very important part. Here x is equal 3 and this x is already belongs to this interval, means every time your left hand limit for the function, the value of the function at a point x is equal 3, and right hand limit your function will be, your fx will be 3x square minus 4. Actually why it is, listen, let's see here at x is equal 3, what is the fx? I need to find what is your fx where x is equal 3. So listen students, x is equal, of course here they are giving what, 2 is less than or equal x is less than, means your x should be between, your 3 is, of course it is, your 3 is between, where your 3 is between 2 to 4. Is it clear? So means if I am taking, suppose that I am taking here, it's a supposition students. Listen, your here your values are 2, 3, 4. You can take also the real numbers. Okay, so 2, 3, 4, but this is not 4, it will be 3.999. okay, in this bit, not because x is not equal 4, but x is, of course we can take here the 2. Okay, so 2, 3, 4 dot 3.99 or something, but not 4. So this means your fx is what, your fx, this x, this interval is valid at a given point x is equal 3x square minus 4, your fx will be, so 3x square minus 4. Okay, so let's tell me, so what is the value of the function by at 3, at x is equal 3, that will be give you 3 into 3 to the whole square minus 4. So it's a 3 into 27 minus 4 means, sorry, it's a 9. 9 3 are 24, 27, 27 minus 4 actually. It's a calculative error. So 9 3 are 27 minus 4. So this will give you 23. Okay. So f of 3 is 23. If left hand limit and right hand limit are also 23, this means your function is continuous. So now let's check here. What is the left hand limit? Left hand limit means limit x tends to 3 left, means where x is, your x should be, that is approaches to 3 left, means it is 2.999. Of course it will refer to this interval, because 2.999 will be belongs to this interval. So fx will be 3x square minus 4. 3x square minus 4. Okay. Now what we have to do? We have to done here, h is approaches, if h is approaches to 0, so your x is what? 3 minus h. Is it clear? So now put here limit h tends to 0. So 3 of your x, what is the value of x is right now? 3 minus h. So 3 minus h to the whole square minus 4. Now students, I need ink actually. Wait for, I have another marker, I will use this marker also. Sorry. So limit h tends to 0, limit h tends to 0. Now students, open it. 3 minus h to the whole square, it is looks like a minus b to the whole square. So 3 and it's a 9 plus h square minus 6h minus 4. So students, see here, this term and this term already 0. I am not multiplying directly. Listen student, 3 9 are 27, okay, and this is 3h square minus 3 6 at 18h, but 3h square and 18h, that becomes 0. So 3 9 are 27 due to h tends to 0. So 3 9 are 27 minus 4. 27 minus 4 is what? 20. Listen, I will multiply limit h approaches to 0. So now multiply 3 9 are 27 plus 3h square minus 18h and minus 4 student. So this term and this term becomes 0. So we have a 27 minus 4, and 27 minus 4 is what? It's a 23. Is it clear? Now ready for the right hand limit. I will solve here. Right hand limit. Your fx, of course it will be same as 3x square minus 4. So limit is h tends to, I will solve directly. H tends to, okay, listen, x tends to 3, right? This is the symbol 3, right? Your fx will be 3x square minus 4. I have already told you why it will be, okay, because 3 plus means the value of x should be 3.99 3.00. Of course it will be lies between this interval, okay. So the function will be 3x square minus 4. So 3x square, so if h tends to 0, so x will be, then x will be 3 plus h. So students, write here limit h tends to 0, okay. If x tends to 0, so it will give you 3 into x square, means x will be 3 plus h, 3 plus h to the whole square minus 4. So it will also, after calculation you will see it will be 23. Has proved here, we have proved here. So that, see here, so f of 3 is equal left hand limit is equal right hand limit. So the given function, is continuous at x is equal 3. If you like it, please subscribe my channel and also press the like tab. Okay students, that's it. So the function you have learned, the function is continuous when the limit should be exist, means the LHL is equal RHL, and that is also equal value of the function f of 3 here. F of 3 is equal LHL is equal RHL. That means the function is also continuous. So students, I will tell you something more. If f of 3 is not equal left hand limit, so function is also discontinuous, okay. But This is the first part of my question. Okay, so in this way, thanks for the watching. Enjoy every day. Bye.